Hi guys, Dean here again, and our series on how to learn to be a C# developer. This being part 2 of how to use a database. The first part was how to install SQL Server and the basic usage of SQL Server, the CRUD functions and so forth. And this time we're going to be climbing into an actual application that's going to be talking to a SQL database. The SQL database is going to be the one we installed last time, which is SQL Express. But basically everything from here goes the same as if it was the developer edition or any other edition. It's the same. All right, so although we're looking at Express here, it tells you up top here it's Express. This is exact same as what you would be presented with a full-blown version of SQL Server. Okay, so if we jump right into it and we get to Visual Studio and we say we want to create a new project. All right. Now remember I did say in the beginning of this series that we are going to be concentrating more on .NET Core, not the .NET Framework. All right. So keeping to that, when I say create new project here, I'm going to choose a C# app. It's a console app. And all right, so we've been presented with a .NET Framework or a .NET Core app. Okay, so like I said, we're going to go the .NET Core route. All right, purely because .NET Core is probably more the future of Microsoft, especially when it comes to multi-platform software. You can run on Linux, Windows, and Mac OS. But all right, so we select that and we say next. And it'll ask us for our name, and let's call it, what shall we call our app? Let's say our first database, or let's say our first database. Okay, and it'll be saved there. You can choose where you want to save it and so forth. I normally leave this place solution project in the same folder. I'll just leave that unchecked. So just type in the name of your project. That's it. All right, and we go ahead and we say create, and that takes a little moment because Visual Studio is now doing all the scaffolding for a .NET Core console application for us. All right, and here we are presented with our .NET Core Hello World console app. We worked on one of these previously, if you recall, one of the previous episodes in the series. But this time we're going to modify it so that we can communicate with the database. Now, there are many ways of communicating with the database in C#, and different libraries you can use and so forth. But a lot of the guys might remember back in the day we used to use system.data. And that is a .NET Framework way of doing things. I think there's a copy of it now in .NET Core as well, but you can still use that. But that is sort of considered a bit of an older way, but there's nothing wrong with it, but it is an older way. Many years ago, a lot of other development frameworks started using what they call ORMs, object relational modeling frameworks, of which, for instance, some of you Java guys will remember there was Hibernate. I used NHibernate and later in specific Fluent in Hibernate, and then ultimately wrote my own ORM. And so then Microsoft came out with their ORM, a little bit late to the party, but they did come out with one called Entity Framework, or just EF, but Entity Framework. And I think it's from version 5 or 6 they've made it open source, which is good, showing they're supporting the community. Okay, now this is a .NET Core app. Now, the way that things work nowadays, if you want to add something to a project, like for instance, in this case, we want to add database support, okay? You have to add it through what they call a NuGet package. All right. Now, in previous versions of Visual Studio, NuGet was a fairly new thing, and there were just some things you would install, maybe a Newtonsoft serializer. But nowadays, a lot of things are installed via NuGet. Okay, but I think before we do our NuGet installation, let me just show you a little bit about SQL Server. So Remember previously I mentioned to you that when we're in SQL, we can use the SQL Server Management Studio, all right, to talk to the database. And then when we were doing the installation, I said you have the option of installing SSMS. You don't have to, all right? There are other clients that can talk to SQL Server, such as Visual Studio itself. So what we'll do is we'll keep this minimized, all right? But in Visual Studio itself now, if you come look up top here, on the top left, one of the tabs here is Server Explorer, all right? So if you click on that, and come now, just expand that. All right, so it's telling us, all right, that there's a thing called data connections and then servers. All right, servers, we've only got our own server, but and then what's interesting is that we've got all the services. All right, now something that's important is we want to add a data connection. In other words, we want to connect to the database, all right, in our application. So we need to add a new data connection here. Now, sometimes you can do all of this by hand, all right? But I'm just showing you how, when starting off, this is how you'll do it. So on data connections, all right, you say right mouse click, and you say add connection, all right? Not create new SQL Server database, we've already got one. So you say add connection, all right? Now we are going to create a new database, but for now we're just going to connect to the one that we already got. Then it's going to ask us here, so what do you want to connect to? We say we want to connect to Microsoft SQL Server, and you can select to always use this selection, all right? I'm just telling you that it's using the SQL Server provider instead of the LayDB provider. Getting a bit technical, but for interest sake for some of the older guys. Okay, so all right, and we say continue on that. Now, okay. Now it's going to ask us to connect to the database, okay, and make sure that our connection works. So we have to give it a server name, tell it where is this machine now. But the thing is, if we click on this drop down, all right, you'll see it's trying to retrieve a list of servers with SQL Server databases or instances running on them, okay. But when we did the install in the previous episode, episode 8.1, I did say that you don't have to install the Sql Server Browser. All right, the Sql Server Browser is what is required to do exactly what we just tried to do now. So it comes back and says server name, and there's nothing in the drop-down list. All right. So the thing is, we can either, if we know the name, we can just type it in, but let's say we don't know and we need to browse to some servers on our network to connect. This one happens to be on our own machine, but what we can do is, let's just cancel here quick, all right? So if we go and look here at services and we go to SQL, sorry, let me just get to the top again. All right, so Server Explorer, okay, you've got your data connections and you've got your servers. So if you expand servers, you click your own machine name, all right, and expand that and then expand its services. And one of them towards the bottom will be SQL Server, where we are now, SQL Server Browser, okay. And you'll notice it's got a little red stop sign here, okay. That means that this service is not running. If we come to the right hand side here, it gives us some properties about it, okay, and it says that it's stopped and the start type is disabled, all right. So you know, we want to change all this, okay. We want to actually be able to, you know, start this browser up, okay, because we actually have a use for it. So if you go to well, let me close this first. So if you go to open and your Windows button there, and you just type in services or service, there's services, all right, and we click on services, okay. So what we're going to get to now is normal Windows services. If you ever write your own services, this is where they'll be lying, okay, in this long list in here, sorted currently by name alphabetically. So again, if we go down to SQL Server, where's SQL, okay, SQL Server Browser, it's disabled. So if you right mouse click on that, you see you can't start it, okay, and that's because it's disabled. So we come down to properties, all right, and we change the startup type from disabled, and you can choose automatic, manual, or disabled. If you do it manual, that means if you ever are going to run into a similar situation where we are now, where we need to connect to the server, you're going to start it up manually again. Alternatively, you can let it always start when the computer starts up. Most people normally leave it on automatic, but it depends. If you've got a laptop and you don't have more than 60 megs of RAM or whatever, it does take up, everything in Windows takes up a little bit of RAM, so it's your choice. It takes up very little, but it's your choice. So let's put that onto manual for now, all right? And it's still currently stopped, okay? So we need to start it, okay? So we apply that, and then we click on start, all right? And it's trying to start the service. And there we go. We can stop and pause it and whatever. So it's running. So we just say OK, and we minimize this window again. So now if we come back to the Server Explorer, and I suppose that just needs to be refreshed. But all right, so if we come here again to data connections, all right, and we say add connection. Okay, again we want to connect to SQL Server, and we say continue. All right, this time when we click here, remember just now it found nothing. It came back with an empty list. So we click on it. All right. And now what it's doing is it's going over our network and it's looking for SQL Server installations. And it's going to find at least the one on our own drive or on our own machine. Okay. So there it is in the drop down. So we've got one hit, and that's the machine running on our own server. And we select that. And immediately it gave us the option. We can now select to enter database name. Now, normally, if this was not on Windows authentication, but on SQL Server authentication, you will not be able to select a database name because you first got to log in. You got to use your username and your password and so forth. But remember, we're logging in with Windows authentication. So we can just click here and it'll immediately give us a list of possible databases. And there's my company. And we can test it. All right, everything should be okay with it. Click on it. Test connection was successful, and we say okay, and it'll go ahead and create us a new connection. So yeah, you can see it's created us a new database connection. Okay, and all's good. So if we expand that, and we can then click on tables, we should see our tables that we created. So this is what I'm saying. You don't necessarily have to have SQL Server Management Server, in other words, or Studio. In other words, this full-blown install here. But most of us are used to working on this. I don't know what the limitations really are in Visual Studio. I've never really tested it. I normally work in SSMS or the equivalent in the past. But all right, so so you've got your three tables here, and you can go ahead and connect to it and so forth. So I think one of the first things you must do is just see what is the actual what do you call it, the connection string, okay, to actually connect to the database. All right, this is what your program is going to require. So if we go and look at I think this is properties, there we go, connection string. All right, so we can just copy that entire row, all right, all the way through to the end. All right, and if we just paste it here, for instance, just comment that line out and paste it, there's our connection string. Okay, and it's saying that it's connecting to the local, or we want to connect to the local machine, the SQL Express instance of the SQL database installation. Initial catalog is just another name for database. All right, so the database we want to connect to is my company. And integrated security means we don't just supply a username and password. It is our Windows credentials that will allow us to connect to the SQL Server instance. All right, so let's just get rid of that for now. All right, now what we need to, okay, remember in the past I spoke as well about think about things in a very modular way. Okay, things and separation of concerns. Things must be kept separate and so forth. Now, not in this video, probably in the next video, we're going to be creating or writing our first DLL, a dynamic link library. All right, but in this case, we're not going to do it. We're just going to rely on namespaces to separate things. So what we want to do is we need to create some objects, classes. Remember, we had a series on that as well, 2-part series on that. I think it was part 7. But we want to create a new set of classes that we can actually talk to the database. All right. So how ORMs work, object relational modeling systems work, is the object, okay, is basically a class in C# that maps directly to a record in a SQL Server database. So in other words, if the SQL Server database, for instance, has got a table called, in this case, clients, all right, and it's got the columns called first name, surname, email address, cell phone, and age, then you have to create a class in C#, all right, that's got also the names first name, surname, email address, cell phone, and age. There are ways of not naming them exactly that. You can name them something else, and then you can, via something called attributes, do the conversion, etc., etc. But that's getting a little bit advanced for our current situation. So for now, just remember, we must just try and keep the names the exact same between the field name as well as our class names, our properties on classes. Now, that's why, you know, some people, like first name here, for instance, all right, I did stick to camel case here, so capital F, but some people prefer the lowercase f, all right, but most people stick to capital F, and that maps very nicely to your C# class property names. Some people will go so far also as to have sort of a version of snake case in here. In other words, between first and name, they'll have an underscore. You can do that, but then just, you know, either map your class properties via some attribute, or name the attribute first underscore name. But the the property. But the problem with naming a property first underscore name, that is not the way that SQL or that C# actually names properties. It names properties in camel case, capital first letter, and then no underscores, and capital second word. So first name is capital F, capital N. So we're doing it sort of, more the way that C# wants it done, all right? So we don't get confused down the line. So let's say, for instance, if we wanted to connect our little program, all right, to the clients table, all right? We want to read what's in the clients table. So we know we've got 2 records in the clients table, all right? We added them in the previous video. And like I said, the clients table is called clients, okay? I normally call it client, but all right, we call it clients, all right. So what we need to do is, on our first database, in other words, on the project, the top one is the solution. The solution can consist of multiple projects, sometimes different languages and so forth. Maybe C#, F#, Visual VB, etc. But or even C++ stuff. But so all our stuff is going to be C#. But now, like for instance, in the next video, I'm going to say, okay, we must right mouse click on solution, and we must go ahead and we must add a new class library. All right. We're not going to do that in this example though. All right. Just because we're not getting to class libraries yet. So on the project, which is called our first database, we're going to right mouse click, and we're going to add, we want a new namespace. All right. So we're going to add a new folder. Where's new folder? New folder. All right, and we're going to call it our model. All right, and under model we want another new folder called let's say DB context, for instance. All right, so we'll call it class, and we'll call it DB context. DB context. Actually, I'm just wondering if that's going to clash. Let's just call it database context. Okay, so database context. All right, so we've got a class called database context. In fact, I think we should create another namespace called contexts. Okay, add new folder. Where are we? New folder, and we're going to call it context. All right. And then database context, we're going to move up into context. So we drag it up and drop it in there. Are you sure? Yes, we put it in there. All right. And then because it's now added it under context, the namespace is no longer true. It used to be our first database model. Now it's our first database model context. So we need to add at the end here .context. Okay. Normally you don't have to do this. We're just doing this because of the fact that I just dragged the file, like I explained in our parts, our series on explaining object-oriented programming. So, all right. So what we've basically got is we've got a namespace, all right, called our first database model context, and inside that is a class called database context. Now remember, this is modular. Everything is modular. Classes are modular, etc. All right. So in order to start using the way we're going to approach communicating with the database is through something called DB context. And in order to do that, we need to install some things into our into NuGet first, or into our app project using NuGet. All right. So if we just right mouse click, okay, on dependencies here, it says manage NuGet packages. All right. And then what you need to go and do is install. You actually need to install two things. Okay, but we're going to install first just the one, and then later we're going to get an error, and then we're going to install the second one just to show you how it goes away. So the first one is I think it was this core one, but I did write it down here. So let's just take, okay, so it's Microsoft Entity Framework Core Relational is the one that I decided to use. All right, and if we do a search up here for that, okay, it should find us our hit. There it is. It's our first one. All right, and what we need to do is this down arrow here, where we can just click on this. All right, and it'll tell us to install. All right, because this is what we want. We want to install this one. This is quite a nice recent one as well. So we install it. So the NuGet is, and this is all the dependencies it's found that it needs to install as well. So it'll install all dependencies also required. All right. So NuGet is sort of like is sort of like the App Store, or the Microsoft Store, the Google Play Store, and so forth, wherein you can select software and download it and install it onto your device. And NuGet over the years has been getting more and more used by Visual Studio to the point where it's now sort of the standard. All right, if you want to install something in Visual Studio, typically you do it via NuGet. All right, so it's installed Microsoft Entity Framework Relational for us now. All right, and so if I close this window down, it's I think it's this one. Yep. Okay. So if I close that down, all right, you'll notice under packages here. All right. Let me just do this. All right. There's installed Microsoft Entity Relational, and as extras, a few other little things here as well that is gone ahead and installed. All right. So he's going to make sure that relational will work. All right. So now, if we come to our database context, okay, we can say, all right, it's got to inherit. Remember, we spoke in object-oriented programming, the fact that a class in C# can inherit from one other class maximum. So we want to inherit from DB context. Okay, now he doesn't know where DB context is. All right. So what you can do is just go back a little bit and then control dot. All right. And it'll give you some options. It's going to try and find DB context if it's installed via NuGet or whatever the case may be. It's going to try and find it for us. All right, and there it's found it for us, and it says, okay, you can either create new stuff, or you can use this context that's already in existence. That's part of the Microsoft.NET Core. Okay, and that's the one we want to use. So select DB context with a using there. Because it's got using there, it's going to add it to the top where it shows using system, collections, generic, and so on. So if we add it on top there, this DB context will now suddenly be green because it's gone and added the using there. All right. So it's like it's for this class, okay, this class which is called database context, which we created, we want to inherit from DB context, and DB context exists inside, okay, of the namespace Microsoft Entity Framework Core, all right, which was installed using NuGet. Okay, so if we take just that for instance, and all right, and we can then look at well, all right, so now we've got context, so let's just minimize context, and then we've got our models now. Now our models are going to be, the context is something that's going to allow us to connect to the database, and the models is, you can think of as the tables, all right, for now. So what we want to do is we want to create models that's got the same names as the database tables do, all right, which was clients, games, and sales. Okay, so now remember, sales had referential integrity set up, and it was referring to the IDs of games and clients. So let's just start with let's just say clients, all right. So we're just going to create a simple thing as it's going to talk to clients. So we need to, under model, all right, remember you can choose whatever you want to call it, but the de facto nowadays is when you're dealing with your business layer, your business logic, all right, is to stick it into something called your model, all right. There are other names for this as well, all just as valid, but everyone nowadays is using the term model. So, all right, so on model, we right mouse click and we add a new class. And that was, what was it called? Clients or client? I think I said I'd do it the other way. So it's clients. All right. So we add a class called clients. Okay. And in clients, okay, we need to add the properties from here. So what we can do is we can just copy paste this over. Okay. Not perfect, but let's include ID as well. Okay, but just so that we don't miss one. So we'll just copy paste that over. We're going to get stacks of errors now, obviously, because it doesn't recognize what all these commas are and all sorts of things. All right. But what it does recognize is when we change them to getters and setters, to properties, in other words. So ID, get, okay. So we type here get and set. All right. So ID and public. Okay, now because we made ID in the database a big int, that is equivalent to C# long. All right, so that ID is now recognized as a long. Okay, so we can do this with all our properties. So just do it quickly. So we just say public, okay, put a space there and then there, and we can just quickly paste all this down. All right, and then we can just steal the get set side of it and stick it at the end. Okay, and just line everything up again all nicely. Like I said, C# doesn't always do it perfectly for you, especially when it gets confused because of all these red lines here. All right, so ID is a big int, all right, and that means in C# it's a long, all right. So first name is a varchar. Okay, it doesn't matter what length the varchar is. In C# that becomes a string. All right. So everything that's got a string, we can just copy and paste that in front of. All right. Email address, cell phone. Okay. Now age, okay, is not a string. Okay, it is a very small number. We're going to make it on the C# side a byte. Okay, oops, byte. So a very small number, in other words. Okay, now you could put in all your commenting and so forth, which you should on some of these things, like specifically on clients. I normally comment everything that's public facing. So anything that's got public in front of it, because that means somebody else might need to use it. And when they do, there's some description for them, but we can cover that later. And all right, so we've got clients, for instance. So now we've created a class called clients, which refers or which represents the database table called clients, and each property, all right, matches the column or the field in the table. Okay, So let me just quickly show that to you just to make sure. All right. So if we go to clients, all right, if we look at columns, all right, we've got the ID, okay, which is a big int. So in C# we make that a long, all right. Then we've got first name, surname, email, cell phone, and age. Okay, so it's 1, 2, 3, 4, 5, 6 columns in total. So therefore we should have 6 properties in total, which is 1, 2, 3, 4, 5, 6 in total. All right. Now we need to go. Okay, so to connect this client, okay, to populate it with data. This represents only one row, all right, in the client's database. All right, just one row. All right. So if we go to the context here, the DB context, all right, and we say, for instance, okay, DB set. Okay, it's now aware of something called DB set. All right, because of the Entity Framework core that we've added. All right. So DB set, and it's a generic type. You'll understand what that is later. I have mentioned it before though when it comes to generic lists. But we're going to say, all right, it's of type. Okay, so we use those little bigger than smaller than brackets. We're going to say that the database, the DB set is of type. Now we've got to give the namespace. So it's model dot and it's client. All right, and he picks up clients there for us. So we just tab on that. So he says, okay, so we've got a DB set called clients. All right, and we want it to be public because we want to access this from outside of the database context class. So clients, all right. And now he gives us some options of what do you want to actually call your property name. Okay, he's giving you some options like get clients, or whatever the case may be. All right, you choose whichever you want to work with or what the team works on. I would typically say people would use capital C clients or get clients, but we're going to stick with just clients, like as if it's a normal property. All right. And on top of that, then we can again just say get set. Just remember it's a property. All right. And okay, so now if we come to, so if we drop the context, we drop the model, and we come to the program. All right. So there's still one step outstanding, and that is that we cannot connect to the database yet. Sorry, maybe I should just do that quick. All right. So on the database context class, this is the class that actually connects to the database. All right. On here, you need to add a little bit of code here. All right. Let me just increase this size here. Okay. So you need to add, coming up, this piece of code. All right. So I'll just copy it out. All right. And I'll just paste it underneath the property here, and I'll paste that. Okay. So the thing is, he knows, you'll also remember from our part series, object-oriented programming, on configuring, okay, is a method that he is overriding because it was declared in the parent class that we are inheriting from. All right. So that's where this on configuring suddenly comes from. That's why you have to say override there. All right, because you're overriding the one that actually is given to us in the DB context. So when this class gets called, all right, on configuring will automatically be called for us as well, and it's going to try to connect to SQL Server. Okay, but the thing is, he doesn't know what SQL Server is yet. We've just told him that we want to use .NET Core to connect to a database, and it's a relational database. All right. We never told them that we want to connect to MySQL or MariaDB or SQL Server, or we never told them any of that. So we got to tell him that. That's why he's confused here now. All right. Like, okay, options builder, but what is this use SQL Server? He doesn't know what that is. So we need to add another NuGet package. All right. And I've added that here as well, and that is the one specifically for SQL Server. You get some others, you know, like I say, for MySQL, MariaDB, etc. But we're dealing with SQL Server. So if you come again here to our dependencies, right, must click on it and say manage NuGet packages. All right, make sure we're on browse up top here, not installed, but browse. All right. Well, if you installed, it'll already show you. So we've installed relational. If you go to browse now, and then we do a search for this, what we've just copied, the SQL Server one, Okay, it's found it here. It's the first one that it's found. Okay, and it's telling us that we can install it. All right. So if we click on install here, it's the same version as the other one, 3.15, and it's stable. So new one, June 9, so all good. So we're going to install that and any dependencies that it has. Yeah, it gives us a whole list of dependencies it's going to install. Okay, let's just see system. Okay, not system.data, so it looks like that is part of it by default. Okay, so and we just say okay, and yes, we accept all the agreements, and it'll go ahead and it's doing the install here for us. You'll notice that little icon that's yellow, boom, it goes away. So that install is done. So if we click on installed up top here now, remember we're on browse. If on installed, we only had one entry. Now we'll have two. Okay. Sorry, it's because we've still got this search in here. Just take that search out. All right. So now we've got two items inside that we've installed via NuGet. And the amazing thing is, if you go look at our code, suddenly use SQL Server is not a problem anymore. All right. Now, this connection string here, okay, this is from a previous one that I did. Let's just get rid of it. All right. And let's paste our new one in. Now, okay, what I must say to you is, if you're working with strings in SQL Server, in C#, right, you might need to put in a character inside of your string, which is considered a reserved character. All right, you cannot use it like an escape character, for instance. All right, that means something inside of a string. If you want to tell the string, look, ignore all the special characters and escape characters and just use the string as is. All right, you put this what is it? The @ sign in front of it. All right, I can't remember the proper definition of the sign, but the @ sign, you just put that in front of it. So if we go again to get our SQL servers, if we right mouse click on it, we go to properties, we come down here, we've got our data, our connection string. All right, we just select all of that. All right, and we come and we paste it inside there. All right, so it will now say that it wants to connect to the local SQL Express version on this machine. The initial catalog or the initial database is my company. That's the one we created. And integrated security, meaning that we're using Windows authentication to connect, which is great. I mean, that Windows authentication has got no real problems with it. Okay, and in some ways, sometimes certain things are easier, but sometimes they're more difficult as well. So, all right, so we just save that. All right, so, we haven't saved this class either, so let's just click up top here and save everything. So if we come to program again, all right, so let's just on top of console hello world here, all right. I now want to create an instance of the database context class. So in other words, I want to connect to the SQL Server. All right. So now that is lying within the namespace model, okay, dot, and then we've got context, dot, and then database context, all right. We'll just call it context, okay, just for now. Well, I suppose let's just type it out properly, database context, okay, equals new, all right. It'll give us the option of model context, database context. In other words, the same as what's written on this side. So you just press tab and you've got it, and you open and close it and put a semicolon at the end. All right, and that's going to try and connect for us to our database. So now what we can go ahead and do is, let's say for instance we want to know how many rows, okay, are in our client's database. Okay, now remember, it's connecting to the database context class, all right, which contains a property called clients, which is of type dbset, all right, of type clients dbset, all right. So that clients, and it's public, so that clients is the one that we want to try and access, all right. So if we come back here again, so let's say number of records. Okay, and put 0 in there, all right, and comma, all right. Now we can say, all right, so it's database context, so it's our class name, dot, then clients, all right, the property that we want to access, dot count, I think it's count, there's count, all right, dot count, all right, open close brackets, all right. So if we run this program now, all right, well, we're probably going to get an issue from a vast, so let me just quickly switch a vast off here, just for a few moments. Where are we? Sorry, shields control is disabled for now. Okay, are you sure? Yes, stop it. Okay. So, a vast just interferes a little bit when you run your app for the first time. All right, so what we expect is it now to tell us number of records and the value of 2, okay? Because there are 2 records in our database, George and Stephen, okay, in our clients table inside our database, which is what we're connecting to via the connection string. All right, so let's just run that and see what happens. Taking a bit long. We might have an error, and I think I know what it is. It's our primary key. But okay, let's see what it says. Okay, so all right, so it worked. It says number of records is 2, okay, which is correct. There are 2 records in the database. All right, so we can close that down for now. But one important thing I forgot to mention here is on the client's class, in other words, the client's table. All right, this ID here. All right, it's generally intelligent enough to figure out that ID is the primary key of the table. All right, that's why I said it's better to stick to standards that everyone else is following, like using the word ID and not client's ID. All right, unless you're doing a referral to a different table. But the public key itself, or the primary key itself on the class itself and on the table itself, just call it ID. And then what you can do though is just on top of that, all right, if you did have a different name instead of just ID, you could just put in the words key. All right, and that's telling, it's not aware of where key comes from. So we also have to, it's telling us, or control dot. All right, so we'll do a control dot on it. And there's our using option. All right, so we say using, so it adds it to our list. All right, data annotations, and it's added this annotation, this attribute on top of long ID. Sorry, it's a little bit confusing with these naught references. If I just make things a little bit bigger apart, it might just look a little bit easier on your eye to understand how each one of them are separate properties. Okay, now on top of this property, we've added an attribute called key. All right, so we're saying that that is the key. If it had a different name, like main key, it'll still be seen, or main ID, it'll still be seen as the key. Okay, because we gave them the property, the attribute of type key. Okay, so all right, so we've proven that we can connect to the database, okay, and that we can say, how many records are in one of our tables. Now, you might want another table, all right, which we do in our case. We've got games as well. We don't just have clients, we've got games, all right. So if we go look at our games table, okay, so let's just do this. Let's go to games. We'll do the same thing here. We'll say select top 1000. So we can get a list of the columns. All right, so we steal that. All right, now the important thing is it's called games. All right, so on the same level as clients, under model here, we say add class. Okay, and this is the name of our table, remember, so it's games. And it's also going to want the same type of properties and so forth as what our clients table wanted. So we need to be public, long on ID, and then get and set. Okay, and we'll just steal that get set and stick it at the end of everyone. All right, and then this is the thing now. All right, so name we know is a string. Okay, public is a string. All right, but price is money. All right, in SQL Server. All right, the data type if we come to, let's say, for instance, what's it, games, we look at our columns, price is of type money, okay? So let's just say they're public, and like I said, I think money in C# is equivalent to decimal. All right. So now we'll be able to get also a list of how many games have we got in the system, all right, which is currently also only 2, all right. But the thing is, our context, okay, this is the thing that actually does our database communication. It's only aware of clients. We haven't told it to know anything about the games we just added, all right. So our database context only knows about clients. So let's just steal that entire row, and we change that DB set, that model clients, to model games. Okay, and we give it a name as well of games. All right, and that's that. So now if we come and look in, let's just save clients here. All right, if we come and look at program, okay, so we did a count of all our clients, and there's 2 of them, okay. Let's say we now want to do a count of our games, all right, and let's go and add a game quickly. All right, so if we look at games here, we'll say edit top 200 rows. So we're going to add a game. I think we had 2. Oh, looks like I cleared that table out. All right, sorry about that. Okay, but let's say, for instance, so we've got some games. So it's chess, and the price is 50 units of whatever it may be. We've also got 50,000. No, just 50. Why does he do that? 50, no, 0.00. That's, sorry, 50.00. It doesn't do that. It was the change value in the cell was not, input string was not in the correct format. Ah, does that mean it has to be like this? Could be. We'll have a look just now. All right, we might have a problem on our hands here, but not a big deal. I think it's because of the use of money, and yeah, but that should be 50. This looks like 50,000, but all right, that's not a big deal. Okay, another game we wrote, for instance, and by the way, ID, you'll notice, starts on 1. Another game we wrote, for instance, was, let's say, Battle Chess. Okay, and that goes for a little bit more, 100 whatevers. All right, and then we've got, so we don't want 2, let's say we want 3 stuff in here. Like I said, okay, Battlefield 3. Still in the days when they knew how to write simulators or arcade simulators. Battlefield, all right. Okay, let's make it look pretty. Okay, Battlefield 4, and let's just say that is, I don't know, 150 whatever units. Concerns me a bit, all these zeros here, but all right. So we've added to the SQL Server database, all right, by saying edit top 200 rows. We've inserted three games, all right. So now if we come back to our source code here, remember the main always runs first on a console application, like we covered before. And all right, so this number of records here should now become 3, okay, because it's the number of games, games.count. So count the number of games. So if we F5 on that, and there we have it. Okay, number of records is 3. All right, so it's working. We're busy talking to the database at the moment. So let's say, for instance, you want to know what is the name of each of your games that you've got. All right. So what you can do is you can do a search. You know what the IDs are, for instance. They're 1, 2, 3, 4. All right. So if we say, okay, .games.find, okay, and then we say find the game with ID 1. In other words, the key where the primary key is 1. All right. This is why I say, you know, sticking to standards like ID and so forth just makes things easy because everything else works in a similar way. So now it knows we're referring to ID 1, all right? And then once it's found that record, on it, it must show us one of the columns that it's found, and we are interested in name, all right? So we should now get one name back of our very first game, which was just chess. Okay, so it should get chess back. Got an error. What happened here? The key value position 0 of the cell to be defined was of type int, which does not match the property of type long. The key value. Okay, that tells me that I made a small mistake in games. No, that is correct. That is a long. Okay, and then in the database, it's a big int. So that should be fine. And this is also a big int. Okay, so everything is big int. So why? Oh, hang on a second. Okay, all right. I know what it's doing. Okay. So what's happening is this one here, all right, was of type int. Okay. So in C#, all right, if you just specify a number, like number 45, okay, or number 167,000, whatever the case, some number, all right, it sees that as an I32, okay, a 32-bit int, all right. But now remember, we're not dealing with 32-bit ints with our keys. Our keys are bigger than 32. They are longs, okay, which is a 64-bit number, all right. So if we got to do a cast, we got to convert that one, all right, to a long, all right. Now you can't convert anything to anything, all right, and sometimes it leads to losses of data and so forth. But a long, we know we can convert a one to a long because an int is always smaller than the maximum of a long. So we can do this conversion. So if we F5 that, there we go. Okay, so our first name is chess, all right, which is what we expected. Okay. So what we can do now is, let's say, for instance, we want to, in a loop, okay, you guys might like the idea of a loop because we covered loops as a structure in one of our first videos. All right, we're going to do a loop now. It's going to be a for loop, all right, which is going to count up these indexes for us. Okay, so it's going to print out the name of every game in the database, okay, in that table. So we will just change this to say name, all right, and then it'll print out okay, find. Okay, now we don't want to find one, all right, we want to find the value of a variable, which could be 1, 2, 3, etc. All right, so we're going to just call it I, all right. Remember I said we should not call variables things like I, but when it comes to loops, everyone in the world knows what you mean when you just stick an I in. They know you're referring to I as an index, and you know IJ, and they're all okay. So that's what we're going to be doing now. So we're going to create a for loop, all right, for, and then we're going to say long I, not int, okay. Normally most people would say yeah, int, all right, but we want it to be a long because else we got to do a pass here again to long, all right. So we just declare I as a long, all right. And now normally you would start at 0, okay. In fact, let's do that. We'll do it the correct way. We start at 0, all right. But remember, our database records don't start at 0. They start at ID 1, all right. So we're going to have to do a little trick, but let me show you. So, okay, so long I equals 0 initially, all right. And we do this, go through this loop, all right. How many times? Okay. While I is smaller than, okay, the number of rows that are in games, oops, db context dot games.count. Okay, good count. Okay, let's just say quickly I plus plus. I've got a feeling this is wrong, but we're going to come back to it now. Okay, so now it's got a loop for us. Okay, now this loop is starting at 0, and it's going to count how many times? Well, up until it's 1 less than count. So you're going to say, well, that's going to give us a problem because we need to count up to count. We need to count up to 3 to show the third one. You are correct if we do this. All right, we say 1. All right, and we say equal, yeah. Oops, equal, yeah. So count from 1. All right. Oh, this is also because of the int32, I think. Long to bool, cannot convert type long to bool. Oh, sorry, that's because Boolean. All right, we covered this also in one of the first videos. All right, that's an evaluation that it did. They're not an assignment. Okay, it's a Boolean evaluation, so it's going to be double equal. All right, so this is fine. This will work. All right, so we're going to start at 1. We're going to start counting at 1, and we're going to go through this loop and increment I every time we go through the loop until I is equal to the number of games in our database. So in other words, it's going to do it 3 times. All right. But we actually in the C# world, or many worlds, programming worlds, we want to start at 0. All right. That's just how it's normally done. All right. And everyone understands what you're doing. So we don't want to count till it's count. We want to count until it's just less than count. Okay, so you can say well, smaller than count, okay, or the exact same thing will be or equal to count minus 1. Oops, count minus 1. It does the exact same thing. All right, so if I run this now, okay, I is going to increment, okay, and every time it increments, all right, it's going to print out the new name. So we're going to have 3 names appearing now. So if we F5 that, okay, did that work? I can't see from here now. No, something happened here. What stands here? Was the extra code 0? Did it work? It looks like something went through. Exited with code 0. What did I do wrong here? For I equals games.count minus 1. Oh, wait a minute. Sorry. Smaller than or equal to. Yeah, that's what we want. All right. Okay, my mistake. Still didn't work. All right. Object reference is not set to an instance of an object. Okay, which object are you complaining about now? Do you have anything already written here? No, you don't. Okay, so games find I. No. Again, my mistake. Sorry. Just because, okay, it's because I'm trying to show you how to work around this problem of where we actually do things with 0, all right, in loops, but tables, their primary keys start with 1, all right. So now our loop is starting with 0, okay, and it's counting to maximum minus 1. So it'll be counting from 0 to 2, 0, 1, 2. But I, all right, is, remember, it starts on 0. I is 0. There is no primary key of 0, so it's going to fall over. So that must be plus 1, all right. So this is how I'm trying to show you how you should write your loops. But in this particular case, it doesn't make perfect sense, all right. So if we just run that, okay, now I'm pretty sure this time it's going to work. All the silliness will come to an end now. Okay, and there we have it. All right, so there's your 3 games: chess, battle chess, and Battlefield 3. All right. So now, like I'm saying, this is sort of writing it the correct way, but in this particular case, it's a little bit confusing with the table. So let's make it work more consistently with how the table itself works. So we're going to say, okay, start at the first record. So in other words, where ID is 1. All right, and do it. Okay, until you equal to the number of records. So from smaller to equal, so 1, 2, 3, all right? And then we don't have to say I plus 1 here anymore, we just say I, because I is going to start now at 1, and then 2, and then 3, okay? Sorry, that should be, yeah, that's right, okay? So if we run that through, aha, okay. So it's that count of ours that's causing a problem. All right, so it's this count. Okay, so what I think we should do is, let's just print out the value. Well, we'll debug it. Okay, so what we'll do is say long records equals boom boom. All right, and so we'll just put a breakpoint on records, and it's going to tell us what the count is when we F9 onto it. All this will, it's Greek at the moment, but it'll make sense pretty soon once we do debugging. Debugging is your best friend, but it also teaches you lazy programming. But anyway, all right, so we've broken into the code now, so we're busy debugging is what you call it. Okay, so if we F10 on that, it'll take us to the next row, or try to take us to the next row, and this is where it's having problems. Okay, so let's see, records is 3, so it does work. Okay, so maybe things have just been slow, possibly. Let's just see. Yeah, it works. It appears that things are just slow. Let's just F5 that again. Yeah, there we go. All right, so it did work all along. It was just extremely slow. All right, so what I've done is I've changed the for loop. Okay, so that it makes more sense if you think of it of how a table works, starting with a primary key of 1. All right, but you can't rely on those primary keys always being, you know, incrementing by 1, 2, 3, 4, 5. Somebody might have deleted 4, so it's not, you know, it's 1, 2, 3, 5, 6, 7. There's no 4. So going through a loop like this, you can't rely on these numbers being actual records that really exist. Just showing something to you now that we know those records exist. I just created them, and I'm showing how you can use a loop to step through and list, you know, all your records. Okie dokie. So the next thing what I want to show you is how can we add something to the database. So let's leave, okay, this loop here, which is currently returning 3 games to us, and let's add a new game. All right, and then also list that. All right, so sorry, we only need to steal the database context dot games. Which table are we referring to? We're referring to the tables. Okay, and we say dot add. Okay, now yeah, there's many shortcut ways of adding a new class. I'm going to show you the shortcut way and the long way. All right, so our class does not have properties. Sorry, it does have properties, but it does not have a constructor in which you can set those properties. So there's a shortcut that you can do in C# to make it as if you did. So what you do is you say, okay, so 2 games, we want to add a new game. All right, remember we're dealing with a games model. All right, so we need to create an instance of our games class. In other words, this class here, which we want to put into this database context. Yeah. All right, so what we do is we need to say new, and then it's in the model namespace, and it's dot games. All right, and open close brackets. Remember, there's no constructor. Okay, now if we just put a semicolon here, okay, that'll be fine. All right, the problem though is when we run this thing, okay, like what we call it now in design time, everything seems okay, but in runtime it's going to cause us problems. Okay, because a game name may not be null. All right, and if we just try and add this game now, all right, that string of name has got no value. It's a null. All right. And therefore it's going to fall over. It's going to crash. So what you can do then is this is a shortcut way to set properties if you don't do it through a constructor. So once you've declared your object, all right, then just open and close squiggly brackets, and inside there press space, and it'll show you what can you set. Now ID we don't want to set because that the database is going to set for us, but name and price we do want to set. Now name is a varchar, okay, so name equals, okay, some name, and let's call it head over heels. All right, let's see who of you know what that is. All right, head over heels, comma, all right, and it gives us the remaining options. So we've got ID and price, so we're going to say price, and the price equals, let's say, it's a nice little cheap game, okay, $25, or whatever your unit is. All right, so if we run through this, sorry, if we go look at the database, all right, and if we, where do we refresh this now again? I forget. Open, navigate. I can't remember where we refresh this, but let's just say, what are we looking at? Games. So, all right, let's say games, select top 1000 rows, all right, and we execute it, and we've got only our 3. So yes, so it looks like those commas was yeah, so this is the decimal was correct, so it did put it in the correct way. So now we're going to have another record added, ID 4, okay, and its name is going to be head over heels, okay, clue ZX Spectrum 16K, and it's going to have a value of $25. All right, so if we go and look here now, all right, if we just run this through, okay, so it should go and add that game in this row here, and then it should list them all for us. So we should now have 4 items being listed. Okay, didn't add it. Let's see. Did it add it to the database? No, it didn't add it to the database either. Aha, so we've got to commit it. All right, once we've added it, we've got to commit it. Okay, and purely just trying to work from memory here, I think that you have to say database context and then dot probably commit or something, or save changes. All right, you can save changes async as well as a by the way, which is quite handy. So it can do save things in the background while you're busy doing other stuff. But okay, so we're just going to say save changes. And let's see what he asks us for. Accept all changes on success. Yeah, that's fine. All right, let's just leave it like that. Okay, and Control S, and let's run that through again. Okay, it's taking so long again. I don't know why this keeps happening. Let's kill it and let's just put a breakpoint here again and see what happens. Just make sure it's built. Run it again. Okay, so there it's broken into our code. So this is where we're actually creating the game. All right, but we haven't sent it to the database. Okay, now we're actually saving it. All right, and now the count should be 4. Okay. So I don't know if we can hover over it. I doubt it. Yeah, no, it doesn't. But okay, let's F5 it, and it was too quick. We couldn't see what happened. So now we've already added this. So let's not re-add it. All right. So let's just comment that out. Control KC. So it's commented it out. Okay. So we should now get 4 games back. And in fact, if you look in the database, if we refresh here. Okay, you'll notice it added head over heels twice. Okay, we ran that thing twice. Now we should actually not allow the same name in our database. All right, that is done. I'll show you how we can do that now. So, all right, so if we come back here, I think it's on our breakpoint again, or something. Yeah, it's on the breakpoint. Okay, so let's let that go through. And I don't know, Windows is having some kind of problem here with, let's just run it again. I mean, it's working, but why does Windows not want to show anything? It's okay, there we go. All right, so there you can see the same problem. Okay, head over heels was added twice because we ran it twice and it added it twice. So it did the correct thing, all right? But the thing is, in our business logic, all right, in our business model, we don't want to allow that, all right? So now you can either, you know, when somebody tries to add to the system, you know, when they add a new game, all right, like here when they add a new game, maybe in a property you can say, well, let me just show you how to do this with a property. So if we do that, let's say we want to add another game, all right, so let's just do this. Okay, but so we'll call it just our new game. Okay, now this is a long-handed way of doing it, but that's just as good. So then you'll say model dot games what is it, new game equals, all right, and then we paste all that. Okay, so it'll go and create a new game for us, but we don't want to do the shortcut thing here. All right, so we've actually created a game, all right, and then we want to say, okay, so the new game, come on, I forgot the semicolon there, the new game's name is, what can we call it? I don't know, Grow 2. All right. Okay, and then the price of the game is going to be new game dot price equals 75 units or whatever. You could make a 75.25 or whatever, but because it is a decimal, so it does allow floating point numbers as far as I know. Oh, it looks like, does it not? Ah, interesting. I don't know why I would have forgot to something so silly. Okay, but so we're going to add another game, okay, called Grow. All right, we're going to add it to the system. We're going to save the changes, and we're going to try and display it. And let's see what happens. So, all right, let's run it. So not running now. There we're running. So for some reason it looks like this window, there it closes now. Okay, so we added Grow. Okay, so we should have, if we go to the database now, all right, and we rerun this, execute it, F5 it, we'll see Grow has been added now as well. Okay, but now we've got two head over heels. All right, now you can write, okay, a query here. Okay, delete from, and then it was db. Remember, this is a normal CRUD method to do a delete from dbo. What are we in? Games. Okay, where, and then it is going to be id. Remember, your where clause always equals, and that would be, whichever one I want to do, 4 and 5, because they're the exact same basically. So let's say I want to delete 5. All right, if we say that now, and we select just that, and we execute just that, okay, then, and we do a reselect of everything, we'll go 1, 2, 3, 4, 6, 5 will be gone. All right, which is good. That's what we actually want. All right, we made a mistake by entering this, but there you can see where I'm saying your IDs can change. You can't count on them as always incrementing one after the other, and there's no deletions. A lot of the databases, they do not allow you to delete a record, rather setting a Boolean field saying deleted, for instance. It's just for historic purposes, keeping old data and so forth. But I'm just saying it is possible that your ID, your numbers are not always following each other exactly. So all right, so if we go back to our C# class, so if we want to delete, okay, just that one record, let's see how we're going to do it. Where are we? Games, sorry. Games dot, is it remove? Yeah, games remove. Okay, and then we've got to give it the ID we want. I think it was 5, which we wanted to delete. All right. Don't know why he's complaining about that. Can I convert from int to... hang on a second. So you first got to find the game. All right. Okay, that makes sense. All right, so what we can do is this. All right, so we find the 5th one. I think it's the 5th one that we wanted. Let's just make sure. Yes, number 5. All right, we found number 5 that we want to get rid of. All right, so what we do is we tell the database context class, okay, and the games property that we want to remove, okay, a particular game. Now it doesn't deal with ID. It deals when you say remove, it actually deals with the generic type games, model games. All right, so we need something to find that game. Now we've already done it here. We found the game based on the ID, and then we also printed out its name. So all we need to do is find the game based on the ID we want, which is 5. All right, and remove it, save our changes, and then if you go through this loop again, we'll find that that game will be missing. All right. Oh, again, sorry, my mistake again. I cannot send through an int. It's because I declared them as longs. So we're going to cast that to a long. Okay, my mistake. Okay, just let's just make sure about the database here. So if we don't delete that, just comment that out for now. All right, let's just run this again. So we've got all our games. There's 6 games in total, and we want to get rid of the 5th one. So it's going to be 1, 2, 3, 4, 6. Okay, so let's run it again. Okay, and okay, that's good. And there's a reason why this fell over. Okay, it's because count is now bigger than what the actual number is. So 5. Okay, so this is, don't worry, this makes perfect sense. Okay, but if you now get rid of this code, all right, so you don't want to do another delete. Control K C on that. Just stop it from running up top here on the red little square there. All right, and if we run it again, it'll show you the right ones, but let's just quickly go and look in the database. So we've got 1, 2, 3, 4, 5, 6. So we want 1, 2, 3, 4, 6. So let's re-execute the select, and there we have it, 1, 2, 3, 4, 6. So our one head over heels is gone. All right, and there you have an example of your ID going 1, 2, 3, 4, not 5, but 6. All right, so don't count on your IDs always being, you know, they will be unique because that's the definition of an ID. But the thing is, they may not exist in sequence as in 1, 2, 3, 4, 5. They could be, there'll always be one bigger than the next one, or small. The next one will always be bigger. But the thing is, you don't know what the next number is because of deletions and so forth. Okay, and that's basically that for, so we've, for our CRUD stuff, we've done an insert, we've done a delete, okay, and now we need to do an update, okay. So, to do an update, I haven't done this in a while, because I don't really work C# at current moment. So if we go, okay, let's create a new game. No, hang on a second. So what we want to do, we want to do an update. So it's quite clear that we're going to have to retrieve a game. Okay, let's let's do that. So let's just get rid of this. So let's say, so our current game that we've got, model.games, I just call it bad game, equals, now we go and look for that game. We happen to know that it is, let's say for instance, the 5th game. Again, I forgot, I must put a long in there. If you're using ints, then you don't have to do that. Most people are probably going to be using ints, but all right. Okay, so what we're going to do is we're going to find that game. We're going to retrieve it out of the database. All right. And once we've got the game, we want to remove the game. Update the game. All right. So let's say that game's name we want to change, for instance. Okay. Okay, so there's our update. Okay, and what it takes is a game that has been modified. So we've retrieved the game from the database. We're not creating a new game with same properties. We actually retrieved the game from the database. So let's see, it's 5. What is 5? Sorry, 5. 5 is the one we deleted. So let's say GRAW. Okay, so it's 6. We want to retrieve 6. Okay, and we want to change it from GRAW 2 to GRAW 3. All right. So so we want to retrieve ID 6. Okay, and this we'll call them GRAW 2. All right, and on GRAW 2 we want to change the name .name to GRAW 3. You can change the price as well, etc. But we're only going to do that for now. All right. Then we're going to say, okay, so you want to do an update. All right. And we're going to pass him we're doing an update of games. So we have to pass him a game, which is GRAW2, our instance of our class that we created up top here. All right. So we do an update. All right. And we save the changes. All right. And so we had a GRAW2. And let's see what we get now. Okay, again, it's falling over here with this loop. I don't know why this loop keeps doing that. Oh, of course, because our primary key is now no longer in order. All right, this is what I just explained just now. It's no longer 1, 2, 3, 4, 5, 6. It's 1, 2, 3, 4, 6. Okay, so we've got a missing one. So the moment we try and retrieve it, it falls over, obviously. So this loop is no longer valid for us to just go through a list of printing everything out. All right, but so it's done its save. All right, and so GRAW2 should no longer exist, but we should have GRAW3. So if we look here, GRAW2, number 6 here, or ID 6, GRAW2, all right, is going to change to GRAW3. And there it is, GRAW3. All right, so we've done a create, we've done a remove, create, what have we done? We've done a create, a read, update, and a delete. I think we've done them all. I might have missed something. I think we've done them all. All right, so that's the basics of doing your CRUD functions in a .NET Core application. All right, so we have not gone very deep into using SQL. That's more going to be used when we start actually writing our major application, which I did say was going to be probably written in Blazor. And in there, we're going to be doing a lot of database communication and so forth. This is just an introduction. So what I've basically shown you today is how to get a .NET Core 3.1 app talking to SQL Server and being able to do your CRUD functions on it. And that's that. And yeah, so I'm not quite sure what the next one's going to be, guys. I think it's probably going to be either the writing of the DLL. Probably it's going to be that. But all right, so enjoy it. And again, I hope you learned something. Please give me a comment if I'm helping you in any way. It just gives me some kind of idea that someone's getting something out of my help. Okay, and thanks a lot, guys. See you, man, next time, eh? Goodbye.